Good morning. Welcome to the Maritime Decarbonisation and the UK Ports Response via Clean Maritime Projects webinar. My name is Helen Stephen, and I'm the Business Development Director for the Ports and Terminals Group at the Society of Maritime Industries, the trade association for the maritime engineering sector in the UK. We're delighted to be joined by so many participants this morning, so thank you for joining us. And this webinar event follows on from our annual Trends in Shipping review that was held in November 2021, where we promised to return to the topic of decarbonisation in detail and look at some of the projects that are underway in ports as we continue our green transition. We intend this webinar to provide a unique opportunity to understand more about the challenges driving UK ports, their steps to accelerate net zero, and the part they play in the future green port ecosystem. We also hope to provide stakeholders within the maritime engineering and technology community with a platform for direct interaction and engagement, and that the value in sharing insights may also drive possible cross-sector opportunities for further collaboration too. So the format of this morning's webinar will encompass a series of presentations covering key themes on green shore power connectivity, smart systems that help us utilise renewable energy, and on-site fuel generation and vessel refit projects. We're exceptionally grateful to have speakers joining us from the Port of Aberdeen, Port of Tyne, Siemens, and University of Brighton to deliver these presentations today. After the presentations, there'll be an opportunity to join 3 similarly themed breakout rooms where our speakers will be positioned and ready to discuss the projects in more detail and to answer your questions. You are welcome to utilise the chat function in the meantime, and any questions posted here will be taken to the relevant breakout rooms following. But first of all, to get us going, and to provide a wider context to the presentations and an overview of the great work underway at the Connected Places Catapult, I'd like to introduce Tom White, Ecosystem Director, and Richard Holland, Principal Engineer, who will present on the UK's future green port ecosystem and introduce each of the subsequent speakers. So, Tom and Richard, over to you.
Thank you very much, Helen. And of course, thanks to the SMI and yourself and the Ports and Terminals Group for hosting us today. After which I think we'll all agree, having seen a number of people join the call, has been a extremely busy few months as we've delivered our Clean Maritime projects. Hello everybody. Yeah, as Helen says, I'm Tom White, I'm the Ecosystem Director for Maritime Ports. I'm also joined by my very good colleague, Richard Holland, from our New Mobility Technologies team, who's been closely involved and leading from the Catapult several of our Clean Maritime projects. But just extremely briefly, for those who don't know us, Connected Places Catapult, we're the UK's innovation accelerator for cities, transport and place leadership, where we're all about market making, and we do that in lots of different sectors, from airports, rail stations, integrated infrastructure, ecosystem incubation. But importantly, of course, is maritime and ports, which is the area that I lead at the Catapult. And we do that from several perspectives: in driving forward climate action to reduce emissions, build resilience, as well people and organizations experience, really taking a design-led approach to future innovation, but also how we can make better decisions, build a better future by strengthening the connection across data and intelligence in our sectors. I won't speak to this at length, but just to say we've been very busy with some fantastic partners over the last 3 years in the maritime sector, as really our climate imperative has really strengthened. We've seen some real change in leadership motivation in the sector to be able to address some of the biggest challenges that we're facing today. And I do recommend to have a look at the Connected Places website and see some of the partners, fantastic projects that we've been working with and in over the last couple of years. Importantly, as we're here to talk about today, the Clean Maritime Demonstrator projects that we've been working with. And really why we've been doing all this is to drive forward the building out of that future Greenport ecosystem, which consists of lots of different elements. This isn't a simple challenge to solve by any means. It includes future vessel designs and the future fuels that they'll be utilizing, as well the role of autonomy and remote operations in the processes at ports, as well how we utilize ports' unique geographic position, not only as an enabler, a facilitator to the growth of our offshore renewables industries, but also how the ports take advantage of many different onshore and offshore renewables themselves to help in their own green mission, as well how ports connect with place and better utilizing our inland waterways. And through ports' roles as multimodal transport hubs, how we optimize the flow of people and goods moving in and around the country. But as well as that, when we deploy future energy systems, we need to have confidence that they are as resilient and reliable, as, if not more, than than the systems that we rely on today. And additionally to that, the port's roles in supplying future fuels, not only to vessels, but also to land-based transport, for example, in heavy goods vehicles or the rail sector, where we've been looking at the potential for on-site green fuel generation, storage and distribution, for example, with hydrogen. But also how we use data and digital to enable a lot of this as complex systems with lots of interactions and variable inputs and supply and demand. How we use that data to make better decisions in terms of what we invest in, but also in managing those systems in the future. And why are we interested in all this from the Catapult? So we exist to grow the UK economy and increase the supply of jobs and economic growth in regions around the UK. And the clean maritime transition presents a significant opportunity to do that by building on the strength of regional clusters. And as you'll see from each project today, and every project in the Clean Maritime Demonstrator actually, is how it builds on the strengths of the UK. It gives us that opportunity to grow UK business, accelerate our net zero transition, stimulate cross-sector opportunities, deliver wider systemic benefits in supply chain efficiency, and grow the UK global export footprint, increasing our opportunities to export UK IP and all the fantastic research and development we do in the UK. So to go into just a little bit of more detail before we introduce the ports, I'll hand over to my colleague Richard to talk a little bit more about the projects we're going to hear about.
Okay, yeah, thanks, Tom. Good morning, everyone. So I'm Richard Holland. As Tom said, I'm one of the team leaders within our new mobility technologies team here at the Catapult. So you're going to hear more from speakers in a few moments about these projects, but I'm just going to give a very quick overview. So firstly, the Clean Tyne project, so as you can see here, made up a great team from the Port of Tyne, the University of Newcastle, Siemens, ourselves, and the Northeast LIP. So really what this project is about is, well, it's using the data available, so from various metering and measurement systems across the Port of Tyne today. Siemens, along with the project team, have been able to build and trial a digital platform which helps better understand and predict the future demand of the multiple energy sources at the port, multiple renewable energy sources at the port potentially in the future. So by looking at the various use cases and energy consumption of some of the key infrastructure and operations, so such as electrification of cargo handling equipment, for example, ships at berth, alongside the shore, and opportunities for providing shore power to those ships, opportunities for on-site renewable energy generation, for example. The team have explored the benefits and potential business case for increasing digitization at the port to help with optimizing the energy usage for a future green port. The result's really been to define a path to net zero, which has been enabled, or which would be enabled by some real-time digital platforms, such as the one which Siemens has developed and trialed at the Port of Tyne for this project. We've created a blueprint, or a transition roadmap, if you like, which can be replicated in other port environments, as well as other industries. So later on, you'll hear from Ian Blake from the Port of Tyne and Ian Lloyd from Siemens, and they'll provide more detail about the platform. And we'll also share some links later on to the roadmap, which we've developed, which I invite delegates to take a look at. So Tom, if I could have the next slide, please. Thank you. Okay, so the next one, Shape UK. So again, a great team here, large consortium. We've got the end customer, if you like, the Portsmouth International Port. Project was led by the University of Portsmouth, along with ourselves. We've had Lloyd's Register, NGAS UK, Cox Powertrain, Brighton University, IOTIX, Know-Now, and Barter for Things on the south coast. And really driven by the goal of ever higher air quality for the people of Portsmouth and the surrounding area, Shape UK has been investigating the use of hydrogen specifically as an alternative to carbon-based fuels at Portsmouth International Port. So we've been considering not only the technical challenges, but also the business case for production and supply of sufficient hydrogen to meet the demand at the port. There's been multiple sensors and measuring equipment again installed by the project around the port, which have been monitoring the air quality and modelling the impact of the various operations and the impact that has on the air quality within the vicinity of the port. So through engagement with both the port and its stakeholders, we again looked at the opportunities across those various operations and facilities, so such as unloading, storage and collection of freight through Portico down at the port, loading, unloading of the passenger ferries at the passenger terminal, and of course the challenges to be addressed around hydrogen bulk fueling of again vessels at berth. And then finally we've looked at vessels carrying out various operations within the port waters, so such as patrol and maintenance vessels. So later you'll hear from Penny Atkins from the University of Brighton, and she'll talk some more about the development that we carried out with the Cox Powertrain to redesign an outboard marine engine that's capable of running on a hydrogen diesel fuel mix. And it was really exciting actually to have worked alongside NGAS as well to install a modular hydrogen electrolyzer at the port, which is able to produce the hydrogen for that vessel on site. Okay, so next slide, please, Tom. So the vertically integrated cloud-based ports at Teesside. So again, with a consortium here, this again explored similar technical themes around the use of increased digitization at the port to achieve a smarter energy system capable of optimizing usage and exploring predictive maintenance techniques which can maximize the efficiency and availability of some of the key assets at the port. And really we can see from these previous three examples, they're all quite different ports, but there's really a set of common themes and challenges that need to be addressed to enable us to reach net zero within in the maritime industry. Collaboration really is key, as the Clean Maritime demonstration projects have shown us, and really it's very encouraging to see the increasing investment to sustain a sector which is vital for the UK, and it plays such an important part of our heritage. So Tom, I think I'm going to pass on to you for the next one.
Thank you very much, Richard. And just reflecting on all of these, I think one thing that's been fantastic to see is that coming together from some of the largest, most global companies in the world through Siemens, GE and others, as well, coming together with the UK academic capability. Ports around the UK have commercial models, local authority-owned ports, trust ports, together with regional innovators as well. And it's just fantastic to see the ecosystem coming together in this way and delivering real value. So the final one I'll give an introduction to before introducing the port themselves is the Aberdeen Greenport Blueprint project that we've been working on as part of the Clean Maritime Demonstrator. And this was around building out a detailed design study for a green shore power solution at the Port of Aberdeen, but which Marlene will talk to us more about in a moment. But as well as that, we also developed what we've called our Greenport Blueprint together with the port to actually look at other ways in which the port can both deliver green initiatives itself, but how that interacts with the region, taking a place-centric view to it. And with the Port of Aberdeen, we've been working together with the Tyndall Centre and Bureau Happold Engineering as well. So now I will do what they say you should never do and try and give you a live walkthrough of our Greenport Blueprint. Just bear with me one moment. I think this should be sharing the tool with you now. Yep. Fabulous. So we'll share the link to this after the event. Do take a look. But there are basically two things in here to look at. The first is actually strategic foresight methods for maritime about how we think about the future and map out different scenarios of things that we control, things that we can enable, things that we can influence, and how that feeds into our longer term strategy definition for big challenges, like, for example, in greening port operations. So what we did with the Aberdeen project was engage with stakeholders around the region to actually understand those different scopes of where the port has full control, where the port can influence certain changes, and where the port can enable broader changes in both the maritime sector, but also in other sectors as well as a transport hub. And just to show you a little bit more detail of one of these, one of the areas that the ports can certainly influence is around green shore power capability. And in each of these scopes, there are several use cases covering aspects such as green corridors, port-based emission taxation, discounts for clean shipping, port microgrids, on-site energy generation, a lot of the things we're actually talking about here today. But just to show a little bit more in what you can find through the tool is actually understanding what we mean by these different elements of a future green port, and looking at this from a sort of impartial perspective to understand actually with this use case, what is the relative level of its ability to help decarbonize the port in addressing challenges, how strong the stakeholder support is for these particular solutions, which I'm sure you can understand are quite different when we consider things such as green shore power or applying taxation to more polluting vessels. As well, looking at the solution maturity in terms of its technological capability, but also how mature it is to integrate with other systems and how mature our understanding of the funding, financing, and commercial viability of the solution is. And a bit more detail in terms of key impacts and what our expected barriers and key challenges would be in deploying that solution. So I do recommend you go and have a look through the tool. There's quite a few use cases on here, including low emission vehicles, converting to greener fuels, as well things that we can help enable through monitoring and reporting, or automating the disclosure of emissions and reducing emissions of vehicles that use the port, but as well how we optimize the flow of traffic into and out of a port that reduces congestion in our cities and regions around the UK. So I think that's it from me for now, and it would give me great pleasure to hand over to Marlene Mitchell from the Port of Aberdeen to talk in a little bit more detail about the project and the shore power solution we developed. So Marlene.
Good morning, everyone, and thank you to the SMI Ports and Terminals team for the opportunity to talk with you all today. I'm Marlene Mitchell, Commercial Manager at the Port of Aberdeen, and we play a pivotal role in the global energy industry here in the UK, and we partner across a wide range of activity and support multiple sectors on an ongoing basis. And we are lucky enough to be home to one of the most extensive energy supply chains in the world. Today I'm going to talk to you about our recently completed engineering study, which focuses on the provision of green shore power to support the decarbonisation of vessels. And being a city centre port, as you can see from the photograph here, any reduction in emissions and air pollution, noise pollution drives benefits throughout the port community and the wider Aberdeen population. So Richard did reference collaboration and the importance of it. And at the port, we completely agree with that principle. In fact, everything we do is collaborative, and this project is absolutely no different. We worked with technical partners, Bureau Happold and the Tyndall Centre from University of Manchester, as well as Connected Places Catapult. And you heard from Tom just now before I started talking. And they've all been instrumental in supporting the multiple project goals that we were working towards. And we can't forget Innovate UK and the Department for Transport, who funded the study via the Clean Maritime Demonstrator project. I'm not going to dwell on this too much, but needless to say, we have a very long and proud legacy, being the oldest operating business in the UK. But we are very much future focused as an organisation, and we're an evolving organisation, and we're about to enter into one of the most exciting chapters in our history with the transformational Aberdeen South Harbour opening in the coming months. This will give us increased scope and flexibility, and will help us position as a port and the wider supply chain for long-term growth and diversification. So just to give you some context behind why we felt this project was important, our environmental strategy is very much focused on our net zero goals. And these also are in alignment with the Scottish Government targets to be net zero by 2045 or before where possible. It sets out our aim to become an exemplar in environmental stewardship, a sustainability leader, and a pioneer in green innovation, and a keen facilitator in energy transition solutions. As a port, we've already introduced green vehicles and LED lighting, and we see shore power as one of the next elements within our Greenport journey. Shore power also supports the Green Maritime Plan expectations for vessels in the UK to use energy efficient measures by 2025. And it's also looking toward policy indicators for Scottish shipping that we're anticipating from the Committee on Climate Change later this year. Our plans and those of our strategic partners in the region also align with the current Green Freeport bidding priorities, and that allows us to focus on a just transition to net zero, skills development to support growing sectors such as offshore wind, and the generation of new jobs and growth across the wider supply chain. So the DFT Clean Maritime Clusters research study identified Aberdeen as one of two very strong locations for shore power implementation, and that was a driver for us to engage Bureau Happold, supported by the Tyndall Centre, to complete a study to help us fully understand the source and the levels of port-based emissions, as well as undertaking a technology assessment to determine the optimal solutions for us to help deliver carbon savings. And all of this was supported by energy analysis to look at optimal areas that would most quickly and efficiently benefit from shore power introduction. The study looked at all operations across the port, landside and marine, and looked at vessel types, auxiliary engine load factors, and time series data to help us understand demands by day, week, month, so that we would know how we could support the infrastructure at the berths. And it also helped us identify which berths would be most effective to choose at the outset. And thankfully, what we also understood was that we had a green power feed to the port to help us deliver that solution more effectively. So the results of the report, they were really pretty compelling. 97% of all the emissions in port were linked to vessel activity, with over 75% of those being from the vessels at berth, burning NGO for hotelling and running of the auxiliary engines. It also identified the key locations where emissions were at the highest due to heaviest vessel utilisation, and allowed us to get into some really quite in-depth conversations with our users around their net zero aspirations to ensure that we were all aligned and that we could have the best chance for success. Shore power is not the only solution we're looking at within the port, but with scale deployment of other zero carbon fuels, hydrogen, ammonia, etc., some years away, this for us is the near-term solution which helps us to have vessels turn off the conventional auxiliaries and reduce emissions and noise pollution, which is a great benefit for the city, but a huge benefit for the onboard crew and the landside crews that are working alongside. So as part of the CMDC project, we had some very clear objectives. We were looking to design a green shore power demonstrator, build an acceptable outline business case and commercial model that would obviously enable us to move to the installation phase. We also have the Greenport blueprint, as Tom has highlighted earlier, which is a very impressive piece of work. And we're also using this to help us build evidence as a consortium to drive policy discussions, which will, we hope, support consistency around shore power discussions in the UK and possibly beyond to maximise the opportunity for success for all ports that are looking at this as a solution. So very briefly, the general concept that we have aligned here is really close to what we're looking at in Aberdeen with an onshore substation. Thankfully, we already have that infrastructure in place. So that's one piece of the puzzle that we don't have to secure to deliver the project. A frequency converter, cable system, and an onboard shore connection panel. Very straightforward and already proven in the marketplace, which is a great benefit from an introduction phase. So what you see here is an outline of what our preferred technical solution is for the port. We've identified the Point Law Peninsula, which is Albert Quay and Mearns Quay, as the key demonstrator location. And then we spent time with the suppliers and through a very lengthy engagement process to understand how they could provide solutions that would minimize the impact on existing quayside operations and also ensure that safety was not compromised in any way. We did some spatial coordination and technical development of the infrastructure, identified the commercial models. As we say, we've looked at full financial models, and the solution that we've come up with has a centralized e-house, as we call it, where the transformer and frequency conversion equipment will sit within a series of containers, steel containers on concrete plinths away from the quayside directly, but with good access to the existing grid supplies. The grid power will be stepped down here to lower voltages and frequency converted for vessel needs. We'll then undertake a series of trenching for the low voltage cabling to connect the e-house to a series of above ground shore power connection boxes at the quayside, and you can see these identified on both sides of the peninsula here. And then we will introduce a series of mobile cable reels for that final connection to the vessels. It's minimal infrastructure on the quayside. It possibly looks a little complex, but it's actually very small infrastructure on the quayside. But we've also been able to build in to the design for future cabling growth so that we can look to vessel battery charging as we move forward on our project. We also have a delivery roadmap which looks at the environmental, commercial and technical aspects, operational efficiencies and port utilisation. This then drives the conversation with the users as well to stimulate investment discussions, because these solutions are not cheap, to be frank, but the benefits will hopefully outweigh these challenges. So as I say, there are some challenges. There are high capital costs. I mean, we're looking in the millions to be able to introduce this in the port, but again, across different ports that will vary depending on the need for substations, switchgear, cabling. So it's very important that ports understand that the likelihood is this will be a low margin project, and there is currently very limited access to public funding, which can actually make the business case even more challenging. We also need to consider that there can be uncertainty for demand, and that's a key part of the project that we're working through and have been working through with the port users, because that does impact your business case, and the high costs of power relative to untaxed marine fuels can also add to the challenges. For the ship owners, they have their own challenges. Many of them are not operating in a high margin environment, and so they have to look at how they justify the investment. And if a ship is operating between multiple ports and they need a certain level of shore power utilization to maximize their return, and shore power is not available, then that makes that conversation even more challenging within the port, the vessel operator. Grid capacity, now that's a huge element and a key consideration across the entire UK. We're all quite aware that we have challenges within the grid as it stands, and many ports are in locations that are remote and not necessarily having access to a viable distribution network, and it may be then extra capacity is needed to be able to introduce this, and that can be really expensive. And the other part of that as well is that the grid is not supplying green power unilaterally. So that's just one of the other challenges that needs to be considered and needs to be discussed as we move forward. And then the final challenge is around policy. Shore power was highlighted and welcomed as one of the solutions to decarbonisation in the Clean Maritime Plan, but there wasn't any real policy support in place. So it's very important that the Scottish and UK governments look to understand how this moves forward and how we can make it a reality and a catalyst for positive change through regulation and or economic incentives to help the ports and the port community put this in place. But it's not all doom and gloom. You know, we have proven that using already proven technologies and solutions that we can help ports reduce their GHG emissions, as well as noise and air pollution. And it also helps achieve wider electrification aims through the use of the technology. And that's really where we are in Aberdeen. So as we look to our next steps, we know that we can implement this solution and that it is our very clear direction of travel. We are continuing to look at alternatives away, and we're involved in the green hydrogen to Power X project presently, amongst other things. But we know that shore power is going to give us a strong and quick solution. The project data, in conjunction with the information collated in port, has formed the basis of the CPC team's work, and we've provided the transferable blueprint, which looks at the wider, longer term picture of how shore power and other solutions fit into the strategy of greening ports and the decarbonisation of shipping. So it's all very positive. We're looking to introduce this in the short term in North Harbour, in Point Law Peninsula, but we're also looking at how we scale that up within the North Harbour and then also the South Harbour. And that is our project today. Thank you.
I'd like now to introduce Ian Blake from the Port of Tyne and Ian Lloyd from Siemens, who are going to tell us more about the Clean Time project, renewable microgrids, and also introducing the Siemens digital platform. So Ian, thank you.
Thank you very much, Richard. Much appreciated. Can everybody see my screen okay?
Yes.
Perfect.
Yes. Yeah.
Excellent. Hi, well, I'm Ian Blake. I'm the Head of Innovation and Technology at the Port of Tyne. I'm going to quickly zip through these slides because no pressure on Ian Lloyd. Section of the more interesting part as it shows you the product itself. I just want to give you a quick overview on the Port of Tyne's decarbonisation journey and why we chose to get involved with the Clean Maritime Demonstrator project. So, looking at the Port of Tyne, we've developed a 30-year strategic plan called Tyne 2050, covering a range of strategic themes around environment, financial sustainability, health and safety, innovation technology, communities, customers, people, and security and resilience. I just want to quickly touch on two of those because I think they're quite relevant to today's conversation. Those are innovation and technology, which luckily sit within my remit, and environment, which is pertinent to the Clean Maritime Demonstrator project. Each of those two themes have got 4 strands, 4 separate projects. So the data strategy and the smart port strategy are quite relevant because obviously we need to gather data from the electrical infrastructure and able to feed the systems that we're looking to develop. And the smart port strategy is around bringing in new technology and new initiatives into the port to try and modernise and to get rid of some of those old manual duplicated processes that we're currently running. A key part for us is our vision to become net zero by 2030 and an all electric port by 2040. And to achieve these, we're looking to establish a clean energy test bed to bring new technology into the maritime sector. So just covering our green agenda in a bit more detail. As I mentioned, we want to be a clean energy test bed within the next few years. So we're offering ourselves to startups, tech companies, people who've got established technology in other sectors but haven't introduced it to maritime yet, to help them bring their solutions to market and help the UK port sector as a whole, not just the Port of Tyne. For ourselves, we're currently going through the electrification of some quayside plant and machinery, including the purchase of 2 new hybrid cranes, which I'll mention later. We're looking to replace our diesel van fleet. We've got about 20 small vans that the engineers and the infrastructure guys run around in. We're going to replace those with EVs. That's out of tender, and we're looking to install that infrastructure this year. We're looking at sustainable fuels. We currently have an HVO trial underway. We'll get results of that in the next couple of months. Where again, we're after tender for solar panels for warehouse roofs. Hopefully that'll be this year project as well. And we're looking to see what we can do with small and large scale wind turbines. Port of Tyne is the O&M base for Equinor, who are installing the Doggerbank wind farm. So we're keen to see how we can implement wind technology on site to supplement our current technology. We've completed the installation of smart lighting and smart meters around the port, so we're able to control our lighting and get the information on energy usage, which was pivotal for the Clean Maritime Demonstrator project that we're running. And we're currently pulling together our roadmap for renewable energy generation within the port. So this is it's our short, medium, and long-term plans to take us forward. So the challenges that we're finding, I don't think we're unique from UK ports. I think we all have similar challenges. Economies of scale obviously come into play, but generally at a high level, I think we were probably all similar. We're currently operating on a aging electrical infrastructure. Most of our infrastructure is from the 1940s, 1950s, 1960s. It's creaking a bit around the seams. We have numerous substations on site, power access to the grid from various locations. We have multiple sites, 4, 5, 6 discrete areas, all with their own power needs and power challenges. There's an uncertainty around capacity and future energy needs. So we know we want to be all electric by 2040, but we don't know what strain that's going to put on the grid, on our ability to power that equipment. We currently have an extensive diesel fleet, so all of our plant and machinery, from the vans to the forklifts to the cranes, are all diesel powered. Add to that the increase in fuel costs and the changes to red diesel tax benefits offers serious challenges to the bottom line, if nothing else. Interesting to hear Marlene's successes at Aberdeen. Ship to shore power, there's a lot of uncertainty around that at the minute, a lot of discussions around it. Again, there's challenges around grid capacity to be able to provide that infrastructure. And while there's uncertainty around government legislation about the needs for vessels to use electricity while alongside, it's a difficult one for us to make decisions on as yet. Fuels of the future, again, very uncertain. Let's talk about hydrogen, ammonia, nuclear, HVO. Again, until there's some firm decisions made around which way vessel operators, vessel owners are going to go, it's a difficult one. Hydrogen seems to be taking the lead at the minute, but tomorrow might bring a different story. And probably one of the biggest ones, or the biggest challenge for us as a trust port, is the capital investment requirements. Obviously, as a trust port, we need to self-generate funds. We don't have wealthy backers. We're not privately owned. So all profits generated by the company are plowed back into the business for reinvestment. And obviously, at the minute, as I mentioned around shore power, there's an uncertain return on investment. We could spend millions installing shore power infrastructure without a clear roadmap to how we would recoup that money and get the return on that. An interesting quote that I found online the other day is the one on the bottom there. So a successful transition to net zero will require meeting increased demand for electrical power by scaling up renewable, low carbon generation and building enough flexibility in power systems to match power and supply. And that is generally what led us to the Clean Maritime Demonstrator consortium that we've taken part in. So for us, we have our targets have been net zero by 2030, all electric by 2040, as I mentioned. The Clean Maritime Demonstrator project brings us a digital platform which helps identify current and future power needs. So we can now see what power we're using and map out what power we'll need. As I mentioned previously, we're looking to purchase 2 new hybrid cranes to supplement the diesel cranes that we're looking to electrify. So if we map out our energy requirements just on crane usage using the digital platform that teams have created, we can ascertain whether we have enough power to charge those as we are. And the simple answer is no, we don't. So we need to supplement the power we can get from the grid through renewable energy. And again, this system helps us to implement feasibility studies around which renewable power projects will give us the best bang for our buck, which helps us deliver more power to the port for the least amount of investment. So it helps us to take those steps forward in a logical, data-led manner rather than trial and error. So it's much better for the business. As I mentioned, Clean Energy Testbed, we brought on a new innovation manager for sustainability, Eleni, and she's looking at new renewable technology, new processes, and look and see what's on the horizon. So what are the next steps that ports can use? We're hoping to announce our 5G network in the next couple of weeks, hopefully, fingers crossed. And we believe that integration with the 5G network and associated IoT technology will help supplement the digital platform from Siemens much further and help take it on the next steps. And obviously we got to collaborate with some of the best minds in the Northeast, which was fantastic for us. So just to clarify the benefits, the centralization of energy data. Previously to the Clean Maritime Demonstrator project, our clean energy data was spread out across the company. We had spreadsheets in one area for tenants and on-site buildings. We had fuel usage in another spreadsheet and by a third-party system. We had energy mapping audits that we've done previously, sitting with engineering and the electrical team. We've managed to bring all that disparate information together into one pane of glass, so we can see what we're using now, what capacity we've got, and it removes a lot of manual report compilation at the end of each month. So we get a real-time visualization, near real-time visualization of energy usage, scenario planning, feasibility studies, and informed data-led decision-making. And the big one for us is those business case planning prioritizations. I'm sure all of us have got CFOs that need to be convinced about where we're going to target our spend. And if we can come with the data prepared, then that's fantastic for us to help take those business cases forward. So from a next step point of view, we're looking to develop the system. We spoke with Siemens, and Ian will take you through the system in more detail in a second. Integration with the new smart meters that we're bringing online, new IoT sensors that we're going to bring in, different metrics. Can we look at our waste? Can we bring in the gas supplies that we don't have metered at the minute and bring those into the system? We want to automate the data gathering and to be able to have that in a real-time dashboard so we can see that and share that externally with our stakeholders outside of the port. And we want to share the story with other ports, which is why we're talking about it at these kind of events and at larger events and going forward. And hopefully the consortium will stay together for Clean Maritime Demonstrator Strand 2, hopefully, which is coming out soon. Now, before I pass over to Ian, I do have a quick 2-minute video that I'm going to share with you. Hopefully the sound works. I apologise in advance for the voiceover artist. It's the best we can get at short notice, but hopefully it'll give you a quick insight into where we are.
Welcome to the Port of Tyne. We've been connecting people, industry, goods and services for centuries. Now, we're setting sail on our biggest journey ever to create the smartest port of the future, introducing our mission, the Clean Tyne Project, a programme that is en route to help decarbonise the Port of Tyne and reduce energy costs, here to inspire change in the maritime industry. We're on a mission to create a cleaner, more sustainable and more effective way of working, a project that will position the North East and the UK at the forefront of green shipbuilding and maritime technology. The Clean Tyne project has received substantial funding from the Department of Transport, delivered in partnership with Innovate UK. In order to reach the government's plan to position the UK at the forefront of green shipbuilding and maritime technology, there will be £30 million total investment in several initiatives to reduce emissions from the maritime sector. Along the way, this funding will support research, design and development of zero-emission technology and infrastructure solutions. We're excited to drive the Clean Tyne project forward alongside international and local organisations as we strive to land net zero by 2030. Our vision is ambitious, but our goals are achievable. Pushing our real-time digital platform for scenario planning and feasibility studies is already helping to determine the future power needs of the Port of Tyne. We're progressing our understanding of the port's existing consumption and emissions by performing an energy audit, whilst continually growing our clean technology, such as the electrification of shipping and logistics to help reduce CO2 emissions. But our journey doesn't stop here. We plan to lead the way. The Clean Tyne project will help transform the industry with a blueprint for decarbonisation that can be replicated in ports across the UK. We're moving towards a better future. We are the Clean Tyne project, and we won't stop until we achieve our ambitions.
Thank you, everyone. And with that, I'll pass you over to Ian.
Yeah, good morning, everyone. I'm Ian Lloyd. I'm the head of Future Power Systems for our Siemens Smart Infrastructure Power Technologies International Consulting business. We're proud to have been part of this consortium at the Port of Tyne, of course, and we've been able to identify a number of different tricks just to be able to allow the port to be able to consider all their innovation requirements and what they want to be able to do to achieve their net zero pathway. And alongside the Newcastle University, the North East LEP, and Connected Places Catapult, with the port themselves, then we've enabled a real true roadmap for us to be able to consider the replication of the outputs of this port and how they can be transferred to other ports of the future. So this is the tool that we use, is the Distributed Energy Optimizer. It's a tool that we fashioned to be able to be embedded within the port environment itself. And there's a number of key benefits in terms of what we were trying to achieve. Of course, the first instance was around about different types of new technology, how we would be able to consider the implementation of that technology, how we'd be able to digitalize its control, how we'd be able to connect those assets together, how we'd be able to simulate then the effective the impact that they would have on the current network and the connecting network of electricity power feed that feeds to the site, and come up with the optimal sizing characteristics about what could be achieved within with any particular port design. There was a method then in terms of being able to capture that and harness that information in a secure environment that we embedded within the cloud-based processing platform that we have at our hold. And within that, of course, that gives us a secure grid edge technology platform then that embedded within the cloud to be able to link to assets actually on site within the port environment, to be able to secure data, to be able to manage, harness and process and analyze some of those data streams, and really then to be able to start to really drive into some of the prosperity drivers that were likely to be considered across the port environment. And some of those are listed on the right hand side there, but Ian's taken you through in significant detail really in his introduction around about the real values and the benefits of this type of platform and the work that we try to achieve together. So the tool itself, we looked at the amount of investment that was already being completed within the port space itself. Ian already mentioned there's been a piece of investment in terms of digitalization of metering across the port environment, and that could be supplemented with additional monitoring of metering if that was necessary and required. And this graphic here really starts to give the overview around about the different types of solutions. So marked in green is so like the different types of technologies that are already in place across the port environment. There's the building, the built environment. There's of course there's the environmental aspects about what happens at the port, and then there's also the metering that's involved that takes into account electricity, gas, fuel oil, and the transport elements. And what we've done is we've been able to harness them into our energy hub platform that we designed for the Port of Tyne, and then we've been able to consider the topics that are marked in white really on this graphic here, is to be able to consider sort of the amount of short ship power, energy storage, cargo handling, and different types of renewable generation that can be run in coordination with the electrification of cargo handling assets that sit within the platform itself. So this is the design really of the tool, but what we were attempting to do within the program. And then these are the likely benefits and where we were able to shift forward. So where Ian explained, so like the now and the next, really we've been focusing on the electrical power and the onshore power characteristics in terms of constraints of supply that the port wants to be able to condition. But what we're really truly considering now is an ability just to enable sector coupling. And sector coupling is the different areas that have been identified in the graphics in the center there, but also to consider the port ecosystem as a whole in terms of all energy vectors that sit on the part. So in the future, we're likely to shift towards a wider port ecosystem. That this might be on other ports, of course, but the model has been secured in terms of this thinking piece. And in terms of another future element, and there's intelligent mobility solutions that can start to cover the entire transport aspect about logistics coming in and out of the port, and to be able to cover some of the scope 3 objectives of decarbonisation as a whole. So this is the tool itself. You'll be able to access these slides. You see the link that's on there in terms of a web link But if not, just search for Siemens Microgrids and you'll be able to find your way through to the different types of technology that we've applied within the platform itself. And here's just quickly some snapshots that allow us just to be able to demonstrate exactly what we've achieved within the port. So a different set of dashboards that gives us different energy views about what today's view is about energy consumption, and what the simulated aspects about energy use will be in 2040 and 2050 and throughout, and how the port is enabling itself from going from its current state through to a wholly sustainable port environment. There's different views that have been generated within the platform itself that gives us a different understanding about the energy mix and the cross-sector transformation that will likely to be achieved within the port environment, and how the port will adopt new technology and where that technology will be applied across the port's lifetime, and what sort of impact that will have on the electrical characteristics that actually feed power to and from the port environment itself through the current grid. Also different views around about whole energy consumption. So this enables the port to have that single pane of glass, really, just to be able to understand how energy is being consumed from all different assets, electricity, gas, fuel oil, and whatever else. Maybe it could be hydrogen or any other different sources that could come in there. But it gives them an ability just to be able to get access to a detailed platform where they can run different views of reports that come from the platform that are demonstrated in this particular screen. And also there's some additional benefits, of course, that comes in from the platform, is that once you have a digitalized platform, then you're able to advise yourselves in terms of processing. So this is operational quality, really. Alarms, faults, warnings, and events all being captured, but also in terms of the analytics that can be processed. Is anomaly detection can be activated, and this gives us an ability just to be able to really become much more proactive in terms of energy consumption or energy avoidance or energy loss awareness that happens to be within the port environment itself. And some of the outputs, of course, of what we've achieved has been in combination with Newcastle University and the modelling work that they've done in terms of where this is shifting to. So this is the impact of coordination through operational optimization, really, in terms of what can we optimize in terms of the current port environment by the use of a digital platform in terms of a microgrid control. And there's methods really there in terms of being able to avoid cost and carbon, in terms of being able to manage loads and to be able to orchestrate them to operate in their most optimal fashion. And one of the final slides for me, because I'm aware of time and I've just jumped over a little bit, is the amount of emissions. So really we're heading towards net zero goals, and the good news is that there's real ability to be able to achieve net zero within the port environment to 100% by 2050, nearly there by 2040. So we need to accelerate that somewhat just to be able to achieve the port goals by 2030, but also alongside the decarbonisation benefits, there's significant operational benefits when it comes to cost. Now the costs, of course, have been increasing, dramatically recently in terms of sort of like gas and fuel oil that we're all aware of. So the increase in cost reduction due to operational coordination might even be greater than this in the last month or so since the project is completed. And lastly, we'll have an opportunity just to be able to discuss one of the outputs of the project in some of the breakout rooms. We have the Digitalized and Decarbonised Ports Transition Roadmap that's been conducted and facilitated by the Catapult team. And we've generated this as a consortium just to give that ability for second users in different ports and different locations, just to be able to consider what they need to do from present right the way through to their long-term investment needs, just to be able to consider what the impact cases are, the business cases, and what they need to do to apply plans into action, and the investment needs of projects, just to be able to enable them to be able to move forward. So that's it for me. Thank you very much. And I can hand back to the team just to be able to cast on to the next section. Thank you.
Great. Thank you, Ian and Ian. Okay, so now I'm really pleased to introduce Penny Atkins from the University of Brighton, who's going to talk a little bit more about the Shape UK project and how the transition to hydrogen can help reduce emissions in port operations, and in particular give an insight into some of the work done to redesign and retrofit a vessel and engine for hydrogen fuel. So Penny, thank you.
Thanks very much for that introduction. So as Richard said, I'm Penny Atkins. I'm Deputy Director at the Advanced Engineering Centre at University of Brighton. And it's really great to talk a little bit about the SHAPE project that I've been involved with, working with Cox Powertrain, with Portsmouth International Port, but also with a pretty wide range of partners, as you'll see in a moment. So if I just share my screen, no, still faffing. Okay, so let's go back to the beginning. So SHAPE UK, I'll talk a little bit around the project in general, and then specifically about the work package that University of Brighton worked on with Cox Powertrain, looking at hydrogen vessels. So SHAPE, Shipping, Hydrogen and Port Ecosystems, working at Portsmouth Port. And as for Aberdeen, excuse me, Portsmouth is very much an inner city port. So you'll see here from this photograph that the port operations are very much inside within the centre of the city. So air quality is a really key factor for Portsmouth International Port, alongside priorities around decarbonisation. So as a summary, the exciting thing about this project, it was ambitious. It wanted to bring together practical demonstrations of the technologies that could be used with hydrogen to decarbonise a port. So it was exciting and also challenging within the timescales of that project to really bring that together. But I think you'll see that we've produced some really interesting insights and demonstrations of that technology. So it wasn't just hardware demonstration. You'll see from this diagram, rather complicated diagram of the project structure, that there was also a digital twin activity in there from B4T and IOTIX, looking to really map the energy use within the port. Then combined with a work package with NGAS and University of Portsmouth, looking at producing hydrogen on site. And then with University of Brighton and Cox, looking at the use of that hydrogen with an engine demonstrator in a vessel, alongside tasks from Lloyd's Register looking at the safety standards and regulation, with then the catapult bringing all of that together. So just to look at each of those work packages in turn very briefly. So the digital twin package was really focused on looking at robust data management. There were many sensors involved in developing these models to put together a real life representation of energy uses around the port. Then Lloyd's Register, looking at really understanding the regulatory landscape associated with bringing hydrogen into the port. So looking at integrating current standards and regulations, supporting the project. Then the beginning of the practical demonstration was NGAS, looking at producing hydrogen on site. So they have an exciting containerized alkaline electrolyzer that they installed on the port for a demonstration. So literally the electrolyzer was installed and up and running within a day. And then they demonstrated the production of hydrogen on the port to show how that might work. And then there was our work package. So this was looking at retrofitting a hydrogen fueling system to a diesel outboard engine from Cox. So this is new. Cox have never done this work before. And the good thing about this from a university point of view was this was bringing impact to some of the research work that we'd done previously on hydrogen diesel dual fueling. So it was a really interesting partnership. So to talk in a little bit more detail about this work package, I'll just try and move this bar out of the way a little bit. So this is the Cox Outboard Engine. It's difficult to tell the scale of it from the picture, but it's about as tall as I am, 220 kilowatts, nearly half a ton of outboard. So it has a real role potentially in terms of the smaller vessel operations within the port. So our aim was to demonstrate a retrofit solution to this diesel engine, so you could use up to 50% hydrogen within operations, and then think about how we might bring that forwards. So part of University of Brighton's role here was around understanding how the hydrogen might behave within that engine. So we worked with Cox here, really based on some of the modelling work that they'd done and bringing our own expertise in terms of dual fuel combustion here to understand how the hydrogen might behave in the system, and then also how that combustion might occur. So just an example of some of the work that we've done here. So this is the Cox Air Intake System. So you'll see the cylinders here where the combustion's happening, and here is the air coming up to both banks of this V8 engine. So one of the key decisions we needed to make really early on in the programme was around how we arrange the hydrogen injection into that system. So should we use a single injector, which was more straightforward in terms of the hardware, or should we use two injectors, which we suspected might give much better distribution of the hydrogen, but was it necessary to use those two injectors and the extra hardware and system complication that might bring? So we put together some simulations, and you'll see that this shows the hydrogen mass fraction within the intake manifold, with a single injector in the middle and on the right hand side with two injectors. So the white colour in the left hand diagram shows where we had really high levels of hydrogen mass fraction within that intake system. So you'll see that if we have a single injector, really we end up with a build-up of hydrogen in that intake manifold, which is really not what we're looking for. Then you'll see the modelling of two injectors shows that then if we put those two injectors here at the beginning of those intake manifolds, so just before the cylinders, although we get some unevenness in the distribution, it's much better than when we had a single injector. So just an example of some of the work that we did up front of the design of the prototype system, just to help us to understand and implement the best retrofit that we could within this project. So the aim of this project was to make minimal hardware changes. This is partially for simplicity within this short project, but also looking forwards in terms of simplicity of a retrofit system. Clearly we needed a bespoke control system as well, because we needed to design very carefully the control of hydrogen injection into that engine, but also the safety systems that are needed alongside that. And the right-hand diagram shows the injection system that we had, where we have a single pipe system that leads into the two injectors within the two intake manifolds within that Cox engine. So the aim of this part of the project was then to demonstrate on a vessel. So you'll see in the centre a representation of the rib. So this is about a 20-foot rib that we will be demonstrating this retrofit system on, and some of the aspects that we've considered within this work package. So we've talked a little bit about the engine modifications. Obviously, there's significant safety considerations needed to make sure that we're operating as safely as we can be. So this shows you the hydrogen sensor that we'll install within that engine cover to ensure there's no hydrogen leaks within there. But then also there's a range of systems within the gas distribution system on the vessel to make sure that the vessel operates safely. We've used, you can see here, a composite hydrogen tank. So this is a tank that's used in mobile applications on land at the moment. So things like fuel cell buses use this kind of tank from Luxfer. So we've investigating its use in a marine context. And obviously there's some specialist instrumentation needed. So this is a mass flow meter, because we need to understand in detail what the behaviour of that hydrogen system is. So how much hydrogen are we putting into the engine at any one time? And then some prototype injectors to actually deliver the gas from Borg Warner. So an involved conversion here of the boat, initially to put the Cox diesel engine on, and then to add the gas hydrogen supply system to that. So the retrofit was carried out by Subsea Craft down on Portsmouth docks. So how have we done? What are the challenges? What are our next steps? So the challenges we've had within this project to some extent, as you would expect with a short practical demonstration project. So we're still planning to do our vessel demonstration now in June rather than within the project. It was planned for March. And this is really down to some of those challenges. So right now, the supply chain for instrumentation and some of the other components is really very difficult. We had a range of delays from customs to suppliers, which really have caused us to demonstrate late. And also regulatory approval for the operation of non-standard vessels is currently challenging. So we've been working our way through that with the help of Lloyd's Register and MCA. So our next steps really are around demonstrating that vessel and also testing, because for Cox Powertrain, this is a key part of their future fuel strategy. It's really important to them to understand as much as we possibly can from this limited demonstration. So we'll look at the hydrogen combustion performance of that prototype hardware and also consider the performance of the system that we've implemented in a marine context. So for us, University of Brighton will, it's been great to see the impact of some of our work on diesel, hydrogen, dual fuel combustion. So we'll be looking to disseminate that and look for further funding. As I've said, this is really important to Cox's ongoing R&D programme, looking at future fuels, considering a future hydrogen project. So we're making plans with them right now for a follow-on project, really to get the considerable amount of development work that's actually needed to go from a demonstrator to a project, an actual product underway. So the last piece of the jigsaw really is the work from the catapult, which is looking at the scale-up roadmap to understand how we can deliver impact and benefits from the project as a whole. So I'll stop there. Thank you very much and look forward to taking questions in the breakout system.
Thank you very much, Penny, and to all of our speakers for a really informative session. And just to go to show the sheer depth of work that's underway. I'm sorry we lost Marlene due to some connection issues. We're going to set up a call to record the end of her presentation, which we'll make sure is circulated. But for the next section of our webinar, we'll shortly be opening the themed breakout rooms as described on screen. We're very grateful for Howie Chow and Chris Brook from Connected Places Catapult will be joining Richard Holland to facilitate these sessions. So in case you're torn between attending multiple breakout rooms, please know that we will be recording each of these separately, and we'll provide links to the recordings after the event. Hopefully that should make your room selection a little easier. So Sarah's opened the theme rooms now, and you can choose your room by selecting it from the menu bar at the foot of your screen. And Sarah is actually staying here in the main room. Should you have any difficulty, she'll be on hand to help direct you. I'll see you back here. We've got around 15 minutes of questions, and we'll all reconvene back here for reflections and closing comments around 10:25. So see you again shortly.
Good morning, everyone. So yeah, as was mentioned, I'm Chris Brook and I'm from the Connected Places Catapult. I'm going to help facilitate this breakout room. So thank you, Marlene, for joining, and thank you everyone else for joining Shore Power. So really, this is, I guess, an opportunity for the next 15 to 20 minutes to really ask Marlene any questions about the presentation, any questions particularly around sort of shore power and shore power at the port. And what we can do to help enable that, any challenges, etc. So, Marlene, I don't know if there's anything you wanted to say before we kick off, but otherwise, you know, people raise hands or stick a question in the chat, and I'll try and get around to everyone.
Yeah, so Chris, thank you very much, and apologies for dropping out earlier. I'm travelling just now, and the hotel Wi-Fi has been proving to be a bit unreliable this morning, so I won't put my video on. I think it's going to work better that way.
So has anyone got a kickoff question that they would like to ask Marlene?
Yes, I've got one. Hello, good morning. It's Graham Foster from Siemens. How is everyone?
Hi, Graham. Good morning.
Hi, good. Yeah, a great first session. That was really good to hear everything. So yeah, really interesting. So of course, as I work for another division, Digital Industries. So Ian Lloyd, who was on this morning, works for Smart Infrastructure, but we work together quite a lot. Just a question, Marlene. Do you know when you were looking at your shore power?
Yeah.
One of us as Digital Industries, we get involved with these shore power applications quite a lot, and one of the challenges we have is understanding the load. You've got a variance of different loads and operational profiles of various vessels, and dependent what they've got running when they're alongside. Was that considered when you did this this proof of concept?
What we looked at during the project was really the hotel loading. Okay. That was our main focus, because that's really because the turnaround time for a lot of these vessels is not long, but they're not necessarily doing an awful lot more. It's just loading and unloading and all that good stuff, and they'll come in for bunkering and things like that. So it was really just focusing on the hotel loading at this point.
That's right, yeah, and obviously it's all down to operational profile and what kind of vessel it is. You can get large ones that may have cranes on,
and that's
maybe
that's exactly right, but that's not the main. So the area we've picked for the demonstrator project at Point Law, that's not traditionally the vessel traffic model that moves through that area. So we are looking at how we scale up for Aberdeen South as well, and they're the kind of vessels we'll be using as our protocol there, because they're significantly different.
Yeah, are they more for supporting the offshore wind industry?
Not necessarily. They can be, but they can also be in the oil and gas sector. They dive support and construction vessels. Right. They've got much higher requirements. But as I say, we're focusing on one area of the port just now. It was just too big a project to look at the entire port. You've
got to start somewhere, haven't you? You can't try to boil the ocean. Pardon the maritime pun.
So yeah, but I mean, certainly we're still moving forward and looking at how we, what would it look like if we set up around at South Harbour, because we're looking at significantly different vessels around there, and it will be a very different looking solution. We're quite sure of that.
Yeah. Have you got a constrained grid supply there, or is it fairly abundant?
We're actually super lucky in Aberdeen. The Clay Hills station that we get our supply from has a sufficient capacity to support the North Harbour project. We haven't done we're in the process of looking at how we would do that with South, because it's a different feed. But we think we'll be within the realms, but again, we'd still have to do the analytics on that. Okay,
that's good. And I noted from your schematic, I think, was it the Albert or something dock you had?
Albert and Mearns Keys. Yeah, so it's the Point Law Peninsula is what we're focusing on for the demonstrator.
You had one hub, and then you had links off to various stations where you were charging.
Yeah, that's right.
Yeah. No, it was interesting. Thanks.
Thank you for those questions, Graham. That was great. Who would like to go next? Tom? Oh no, sorry, Nigel.
Yes, good morning. Good morning, everyone. Apologies, I was a little bit late. I had a problem myself. I'm based in North Wales. I had the same issue as Marlene this morning. I couldn't get on the webinar for the first sort of 10 minutes. So I missed a little bit. Thanks, Marlene. I found a lot of what you had to say really interesting. I'd be really interested to see the recording and everything else that's going on up there. I'm the Chief Operations Officer for a company called Graph Marine. We're a fairly new organization. We're developing a smart technology and energy generation system. It looks like a PV tile, but it isn't. It's considerably more. It not only generates the power, it stores it. We have an AI system. So I'm going through the early stages of collaborating with a number of people across Europe and in the States. And we've got a couple of installations now in the UK, I'm pleased to say, one in the Irish Sea and one due to go into the Port of Tyne. But we would really like to trial the product, if we could, as far north as we can, because that's as far north as we're going at the moment, is the Port of Tyne. And we're looking at geographical areas around the world to get as much data back. We don't envisage to go commercial till the end of next year, but what we're looking for at the moment, and I say this to everyone and people laugh at me, but we just really want people to wrap their arms around us and say, look, come and trial the product with us, because we really need the people like yourselves to push back, tell us what we're doing really well, and also give us some constructive feedback so we can get the solution as powerful as we can. We feel we've got a brilliant product. We just haven't got enough data coming back for it yet to get us to the next stage to go to commercialization. So the question is, after all that waffle, is how would we be able to engage with the Port of Aberdeen? Are there geographical areas around there where you're embracing small technologies, asking people to come in and talk to you and try? Because we're not looking to sell anything. And I find this very difficult when I say this to people, because people still push back. But I'm saying, I don't want any money. What I need is your expertise and the space and the collaboration to get this product into the marketplace.
So I'll jump in there. So Nigel, really, you just need to reach out to me and let's have a conversation. I can't make any promises at this point, but if it's something that seems to be of interest, then let's talk. Basically, I mean, it's Tom's about to kill me, but you're probably in a good place to talk with him as well, just given his reach. He's looking at me now on the screen, sorry. But the other thing is, we're strongly connected with some of the other ports in Scotland, and particularly the Northern Islands, Orkney and Shetland, and it may be something that we can connect you into up there as well.
That'd be wonderful. I've been working with the University of the Highlands to look at some aquaculture projects as high up as the Shetland, because we're trying to get data from all parts of the world. And the only place I've really been struggling, to be brutally honest, is the UK. You know, it's taken me a while to get through the Welsh Marine sort of setup, and it's worked well. But the likes of the west coast of the US, lots of people are dragging us out to the States at the moment and want us to relocate. But, you know, we're fundamentally a British business. You know, we've got staff in Scotland, you know, England, Wales, and we have a new person starting with us in the Republic as well. So we really do want to establish it here before we go anywhere else and take it forward. You know, we recognise we have to make this thing in different countries because it's there to challenge the burden of the carbon fuel. So we don't need flying it all over the world. But it was just have an open conversation, Marlene. That's all we're looking to do. Nothing more. And I appreciate if it has some value, then there's going to be some interest. If you don't believe it hasn't, then we would fully respect that.
Absolutely, no problem with that at all. I think our details will be shared and they're on the log, so feel free to reach out.
Okay, I'll send you some information first, and we'll perhaps have a conversation when you've had an opportunity to share.
Great, thank you.
Thank you,
Thanks, Marlene. Thank you.
Sounds like a fascinating idea of a product there. Rachel, you've got your hand up.
Well, two things. First, just a quick one for Nigel. Nigel, I guess you tapped into the sort of clean maritime network. You know, there's a couple of events coming up.
Yes, I have. Yes.
Okay, cool. Yeah, I just wanted, because it's, you know, it's a good networking hub really, and there are, you know, sometimes some supporting kind of mojo meeting places where you can, you know, put your ideas in. So if you're looking for people to team up with.
Rachel, it's I think as the industry, I'm reasonably new to the marine industry, although my industry is smart technologies, but in the last sort of couple of years, I think the marine industry is really transparent with their supply chain, and they're really trying to support where we're going. So I have no complaints. I think the only complaint I've got is probably with the Graph Marine team not pushing our name out into the UK strongly enough, really. So yeah, but it would be interesting to see where we go.
Well, anyway, it's good to see a fellow industry person on a call like this, because I think they're great ways of connecting. So thanks to SMI and the Catapult. I guess one for Marlene. Hi, Marlene. It's Rachel from GE. I can see I've got my colleague Phil, who's dropped in to the meeting room as well. And Phil's probably closer to this than I am. But thanks for the stuff about shore power, and caught your presentation at the SMI conference as well, which is great. What beyond shore power? I think somebody mentioned a minute ago about sort of things like grid capacity. You know, have you thought sort of beyond yet, or is it just sort of one step at a time to things like hydrogen production or sort of microgrid updates, that kind of thing?
Yeah, I mean, it's we're very much one step at a time.
Yeah.
We are in conversations around other fuel sources. There's biofuels, there's hydrogen, and I think it was Ian made a comment on, there's just so many options, and it's not necessarily very clear which way the ship owners and operators are going to go. So we're closely linked in those conversations as well. So I mean, the reason for the shore power is that it's a pretty immediate fix. We can move on this very quickly, and we can deliver benefits very quickly is really what we believe and what the project kind of showed for us. But at the same time, we're consistently moving through alternatives and looking at what we can do around as part of our environmental net zero strategy. So it's one step, as I say, and there's a lot more to flow into that.
And fully concur. I think we're on a similar path where the immediate focus is, bringing capability in shore power. Like you say, it's somewhere where we can all have an immediate impact, but in parallel, we're looking beyond that. So, if there's a conversation, I agree with, none of us can be overwhelmed by it, but I think it's good to be working things in parallel, where we're just trying to at least move forward, even in, more of the kind of feasibility side of things, just to look at the impact and potential solutions.
Yeah, indeed. And I mean, it's not, we work very closely with a lot of our port users. They're long-term users of the port as well. So we're all trying to move in the same direction together, which is encouraging because we've got some very significant players.
I'm Howard Chow from Connected Places Catapult, and I will be facilitating this breakout room. I've been working on the Clean Time project with Ian, both Ian's and Lindsay, who's also joined in this breakout room. Perhaps Katrina, if a quick intro, same, and then we'll go around the table, and then we'll go straight into the questions. That's okay.
Yes, lovely. Thank you. Katrina Board from the United Kingdom Hydrographic Office. I head up the ports relationships and other UK data relationships. I met Ian recently, Ian Blake. Hi there. And I was really interested to understand your digital platform and how you brought all of that together, because it looks amazing, actually. And I'm sure there's a lot we can learn.
Well, hold that question. I think that was a good question. How we managed to bring this all together for the digital platform. Okay, thank you for that. Amit, I'm just going down the list now.
Hi.
Perhaps a question from you as well. Sorry, just a question if you'd like to add as well.
Hi, good morning, everyone. My name is Amit Bhave. I'm from CMCL Innovations. We are interested in how to connect data via connected digital twins, both syntactically and semantically, so that we have intelligent decision making. Basically, that's the background. My question is really regarding the how actionable is the data once it's come together. The reason I say that is we are looking at a lot of climate resilience work at the moment, connecting climate models with critical infrastructure from telecoms, water, and other industries as well, for cross-sector digital twins. And I think this work shown by Ian's is quite impressive, and I would like to know how actionable and accessible the data is. Thank you.
Yeah. Okay. Brilliant. David Cooper.
Yeah, good morning. My name is David Cooper. I'm from the Offshore Renewable Energy Catapult. I'm the partnership manager for Clean Maritime, so looking at sort of decarbonising of the operations and maintenance vessels that go out to the wind farms. Although the sort of core focus, I guess, is the vessels themselves, it's very clear that needs to be linked up to port-side infrastructure, things like shore power and potentially hydrogen production or bunkering, depending on what port. And that's sort of taken that obvious interest further on to how you operate things like electrolyzers, whether you base your business plan on sort of high capacity or you utilize it as a sort of grid balancing mechanism alongside things like battery storage. So on that side of things, I have to say, I'm really just interested to hear lots of different projects and the like, and get more information. Also looking forward to coming up to Port of Tyne on to speak on June the 13th. So if any of you are Port of Tyne there, I'll get to meet you in person there.
Yeah, I'll meet you on the day.
Thank you for that unashamed plug, David. If anybody else wants to come along.
Thanks, David. Finally, Douglas. Oh, you're on mute, Douglas.
You're still on mute, buddy.
Let's see if I can do it from my side. No.
Yeah. You're still on mute, Doug.
If you go to bottom left, it's if you see the box with everyone's faces,
right.
There we go. Thanks.
Okay.
Yeah, we got you, buddy.
Beg your pardon. Right, Douglas Blackwell, Crowdhouse Energy. My interest in the renewable microgrid is, at this stage, what level of on-site renewable energy generation are you actually looking at in terms of megawatt scale? And I am presuming, because of your location, the majority of the on-site will be from solar. Or are you looking at putting a wind turbine in there as well?
There's a bit of a mix. There's a bit of a mix, and we might need to follow up with you later beyond that. So, Doug, I don't know whether you're coming to the Port of Tyne event on the 13th of June, and maybe we can discuss that a little bit more, because there's a number of different things. But anyway, thank you.
What was that? The 30th? Did you say?
13th, yeah.
The 13th, yeah. Actually, will be in the UK then.
Oh, wonderful.
Yeah.
Okay, there's a couple of others, Howie, Brad and Paul. Brad seems to have dropped off in my screen anyway. But,
I'll introduce myself quickly. So I'm Paul Wilson, systems engineer from Connected Places Catapult, work alongside Howie. Quite interested in how this could be moved across other projects in the future that we could be doing in future CMDC, and also, as David said, the grid balancing across energy storage and meeting peak demands with the renewable.
Okay. Thanks, Paul. Shall we kick off with the first question then from Katrina, which is, how did we bring this data platform all together? Is that one for Ian, Lloyd?
Yeah. Thanks, Katrina. No, great question. And truth be told, that this platform has been in its creation and for a number of different years now. We've been focusing on different topics in terms of sort of energy management and the capturing of of detailed energy from metering systems, and the way to be able to avoid peak network constraints that happen in the environment. So what we have enabled is multiple different streams to be able to capture information from any asset with any sort of metered or monitoring output, and to be able to feed that into the platform. What we do then is that we nominalize all that data. We ensure that it's all being captured in the same time series. And then what we do then is that we enable widget-based dashboards to be created, and those widgets, I know it's an odd word, but those widgets allow the end user just to be able to define what dashboard they want to be able to look at, and pull them up in terms of like either live events or energy indexes or different types of reports that you create in the background. And the benefit of this then, it gives you the ability, or the end user the ability, just to be able to relay the key information that you may be capturing from many hundreds or thousands of different sources, and be able to to have a degree of transparency over that energy and or any other type of data asset that you're pulling into the platform, and to be able to sort of visualize that in a number of different formats.
So going back to the actual platform itself, where did you start?
We started off with the initial design of the key requirements that we have within the Port of Tyne. So the key drivers really is in terms of what the port wanted to achieve. The port wanted to achieve some clarity in terms of what types of assets that they wanted to connect across the port in a chronological time series to allow them to get to net zero. So based on that skeleton architecture, then we started to understand and started to devise the different types of metering and monitoring inputs that would allow us to be able to conjure up the models that would be required to be able to achieve a net zero port.
Great piece of work. Thank you very much.
You're very welcome. Great question. Thank you.
Thank you. Next question was, how actionable, accessible is the data capture? It's quite a good follow-on from the previous question. Again, I think
it's a great question. That was from Amit, I think, wasn't it? Yes. I think. Amit. So thanks. Great question. I wrote it down. So I've got the how accessible is the data. The data is accessible based on who we want to give access to. Okay, and we have different levels of accessibility that can be achieved. So you can have different user logons, you can have different views, and you can enable people to be able to have the ability just to be able to either visualize or to be able to download, right, the outputs of some studies that are done within the platform, and to be able to then to either export them into their own different platforms, or to do whatever they want to do. So we apply degrees of security around that, and then degrees of select system like operational settings. Very similar to whether you could be an administrator in a computer or whether you could be just a user. But we have multiple tiers of that, okay, to be able to allow people just to be able to access them. The other element of the question that I wrote down as you made it is that you asked about how actionable some of those topics were, and in that action, so the definition of what we sometimes do is many different dashboards give you the ability just to be able to realize what sort of energy that you can do, and then you might need to be able to download the data and then be able to pull that into some sort of reporting tool, then to be able to define some sort of plan to action. The benefit in our digital platform gives us the ability just to be able to drive algorithms, right, that we embed within the tool itself, and then allow them to be able to become to drive real inputs through algorithm-led outputs, right, and then drive them to actions. Howie, I've just got a thing coming up to say that the room's going to close in 40 seconds.
I know, it's a bit, I think they're keeping it to times, we have to go back for 25 past. But there was a question, just the final questions on the solar and the wind power, but I think maybe we take that offline because it's quite specific about the port itself and which direction it will go, whether. And I know
there was one from Doug about the detail of power, but in the 30 seconds that I've got left, I'll try to answer, because there was two questions that came in, one from David and one from Paul around about balancing of energy, right? And the method in terms of the microgrid idea is to be able to capture information, run algorithms, and then being able to balance that in terms of like supply requirements, right? Maintaining security of supply, and to be able to balance energy needs across the port environment to achieve that.
Gosh, that was brutal.
You did manage to finish your point, Ian.
Sorry, Rachel, we didn't.
We were looking at the clock.
But I think you got the gist.
Yeah.
Thanks.
Yeah, thanks, Marlene,
for coming back. Thanks everyone for coming back into the main room, and it's really great to see some of that collaboration already starting. I know we've had some interesting conversations. Tom, you wanted to share some final thoughts and reflections just very briefly before we close up today. Tom, are you able?
Tom, you're mute.
You're on mute. You're able to come. Sarah, can you unmute Tom?
I've asked him to unmute, but I can't actually unmute.
Hello, Tom.
We've actually lost Tom, so I'll give him a moment to see if he comes back on, but he's not on the call anymore.
Well, I while we're waiting for Tom, I really hope you found today's webinar interesting and stimulating in terms of sort of maybe even starting off some of those collaboration conversations. And it's clear that the Clean Maritime demonstration competition is enabling many of these important collaborations, and the extension of it to a multi-year initiative is really welcome. And we're looking forward to imminently receiving more details of the plans to release further funds through UK Shore. Do we have Tom online now? Doesn't look like we do. Okay. Well, I'd like to thank Marlene Mitchell from the Port of Aberdeen, Ian Blake from the Port of Tyne, Ian Lloyd from Siemens, and Penny Atkins from the University of Brighton for their time and significant contribution to today's webinar. And I'd also like to take the opportunity to thank Tom, Richard, and the Connected Places Catapult team, especially for their participation and assistance in the organisation of today's event. I'll be following up to share the output from today's webinar, which will include links to the Connected Places roadmaps that have been referenced today. And of course, if there's any issues that you would like to explore more directly with me, or if you'd like me to facilitate any more connections, or even details of our future ports and terminal groups activities, please do reach out to me at SMI. We're always happy to help. I think we've got Tom briefly back online. If there's anything you'd like to add before we close, Tom, you may have some thoughts. You are muted at the moment, but you are online.
Sorry, Helen, was that me?
Yeah, just any final thoughts to close, or any reflections from your point of view?
Yeah, thanks. For some reason, all my audio suddenly catastrophically failed as soon as I was ejected from the breakout room. Anyway, I'm back. But yes, thank you very much, Helen and SMI, for hosting us today. I think it's been really great to see some of the projects that we've been involved in come together. Like I mentioned earlier, I think what's been really great about things like the Clean Maritime Demonstrator call is how it really shows what we're capable of and the capabilities we have in the UK, from small organisations of 1 or 2 people all the way through to multinationals with tens of thousands of employees distributed all over the world. And I think absolutely 100%. The shift I've seen in the industry, even over the last couple of years, on that imperative, that momentum to actually get things done, I think is absolutely fantastic. And yes, really looking forward to Clean Maritime 2, where we can think on a bigger scale, where we can do bigger things. And if this is what just a brief snapshot of what 3 projects out of the 55 achieved in 6 months through supply chain crises, and we still had the back end of COVID and all the rest of that. Let's see what we can do in 2 years. Really looking.
That's a great call to action.
Yeah,
absolutely. And thank you, Tom. Really appreciate that again. And sorry you had difficulties coming back in, but yeah, absolutely. If you'd like any details about exploring any more issues or connections, do get.
Just to introduce myself before we start, because I agreed to facilitate this session. So the Catapult, we're really pleased to have been asked by the SMI to help organise and facilitate this event. You did hear from me earlier, but as I say, my team and I've been working with the project consortium on 4 of the projects within the 55 Clean Maritime projects, including this one, Shape UK. So I'm really pleased to be here today with Penny to help take your questions on the project. So how it will work for the next 10 minutes or so, it's essentially a Q&A to explore the project in more detail. So you'll be pleased to know that there's no exercise or activity planned, because obviously it's quite a short session. We'd like it to be as interactive as possible. We're still a fairly small group by the looks of it, so please do try and ask questions verbally. Nothing's come through on the chat from the main session, so I don't have a list of questions ready. So please do ask away. Last thing, really, it is quite easy in these online environments to accidentally talk over each other. I say, fortunately, we're not a massive group, so there shouldn't be much of that. But perhaps just to ask to raise your virtual hand within Teams if you can, and I'll so within Zoom, and I'll endeavour to come to everyone in turn. If you do prefer to use the chat, if you can't talk, then obviously type a question in the chat, and I will get through as many of those as possible. So yeah, welcome. I guess, does anyone have would anyone like to start? Does anyone have a burning question? Yes, Richard, thank you.
Hi, Richard.
Hi, Penny. Hope you're well.
Yeah.
Thank you for a really interesting presentation. I've got 3 questions, really, if I may just sort of combine them together. The first is, I assume it was a 4-stroke engine you were using, not a 2-stroke. I mean, is 2-stroke practical with a hydrogen fuel? Thinking about the power weight issue for boats. Secondly, controlling the NOx, which I think is an emissions issue with hydrogen. Are you using a lean burn mix? And thirdly, the practicality of using hydrogen in small boats. I'm particularly concerned about the weight and the volume of that solution.
Yeah, sure. So to pick up those are good questions, actually, Richard. So the way we were doing this is it's a diesel engine with hydrogen fumigated in the intake manifold, which means it's lean because of the air-fuel ratio that you use for the diesel. So the work that we've done, and you're right that NOx can be an issue with hydrogen combustion. So the work that we've done at Brighton, when we looked at up to 50% substitution, showed that the NOx at those conditions was really very similar to just diesel. What we find in the literature is it can improve your particulate emissions depending on how good those particulate emissions are to start with. Do you see what I mean? So if you have an issue with particulate emissions, then the hydrogen can help with making the combustion more complete, and so that can help your emissions there. Is that what you were looking for?
Yes, thank you.
Yeah. In terms of practicalities, the storage, yes, I would agree. So for the vessel that we have, the hydrogen tank holds about 3.5 kilos of hydrogen and takes up a reasonable amount of space. And we'll be looking at 300 bar hydrogen storage. So I think my view is actually, in terms of practicality, the storage of the hydrogen on board is the most important point in terms of making sure that you can store enough hydrogen without impacting vessel operations to do the work that you need to do within that day.
Thank you. I mean, there are hundreds of thousands of small boats around the country all needing a solution for clean environment. Thank you.
Yeah, I think that's why the technology is really important, because you'll see the sort of simplicity of the actual, the physical engine retrofit is relatively straightforward. It's a bit like a CNG retrofit, but you've got to make sure that hydrogen storage works on board.
Brilliant. Thanks, Richard and Penny. I see Anthony, you have your hand up. Morning.
Yeah, good morning all. Yes, Anthony Greater from Eminox in the UK. We are after treatment manufacturers, so
Yes.
very interested in the outputs on this project. Is there any further work looking at that NOx reduction? Because if I saw that correctly, that's a tier 2 legislated engine at the moment. Anything looking ahead to take it to sort of tier 3 or beyond? In fact, I mean, far beyond is possible.
I don't want to speak for Cox on this because clearly that's part of their development plans, but emissions, the plans in terms of development, as you might expect, will include a test cell development phase when we'll be looking at the NOx and other performance.
Yeah, because I mean, an SCR, regular after treatment system is effective on hydrogen as the work showing that we're doing. So yeah, it'd be an interesting next step to take it forwards.
Yeah.
Great, thank you. I noticed Neil Walker's just joined, so good morning, Neil. Yeah, just to reiterate, it's a Q&A session. This, so obviously, if you have a question for for Penny or for myself for the Shape UK team, please feel free to raise a hand and ask it. I see John Haynes. Morning.
Hi, Richard. Thank you very much for the session. Penny, great presentation. I'm following this with great interest, and I would have been with you next week on the 24th, but we're running Next Gen Marine Hydrogen Workshop via Zoom that day, so we've got the classic clash. So I hope we'll catch up separately. Specific question. I'm following this with huge interest. I've got a lot of interest in alternative fuels, but mainly for sub-IMO, sub-24 metre craft. I'm a Brit, but I tend to think sort of from a European perspective, and I've worked a lot in the States and Canada, so I probably have a broader perspective, but always boats, not ships. I'm really interested in the size of vessel. I mean, you're looking at, I know the Cox, I've been down in the early days, I've followed that, great British innovation, etc. The interesting one is, I know that type of rib very well. We'd normally carry 50 to 100 litres of diesel. That's going to be the typical size of fuel tank, which is going to be give or take 50 to 100 kilos. And I know roughly what range it would give me. I picked up obviously on your 3.5 kilos of hydrogen.
Yeah.
It's a classic sort of, weight question. If that vessel would normally have a capability, let's say for argument's sake, of carrying 50 litres of diesel, and you're going to bring in hydrogen, what sort of range do you think you're going to get with that 3.5 kilos?
I think you're absolutely asking the right question, is what I would say. And I think, this is looking for a dual fuel solution. So you're always planning to run diesel alongside the hydrogen. But it's for us, we were looking at the size of the tank is partly for this demonstration is predicated really on what we could get at short notice, and also what we thought we could conveniently fit. So in other words, this is a demonstrator for understanding the technology rather than for an operational environment. And I suppose what I'm hedging around here is we think that the tank would give us, some hours of operation up to 50% hydrogen. And that was our criteria for doing a test demonstrator. But I think there's more analysis needed in terms of understanding the best way of storing hydrogen on board, and could it give you the practical range, because obviously you need to be able to operate the vessel in its commercial environment properly. And I think that for me that is the big challenge with hydrogen in terms of operation in a port environment, because you've got ammonia for longer term, sort of your longer range applications, and maybe other sustainable fuels. There's a lot of interest in methanol here. But I think there's potential for hydrogen in terms of short range port operations, but with considerations around range and easy refueling, which hydrogen can be, but you need to make that really practical within a port environment.
I can maybe add as well that, Penny, perhaps in that John actually may first just check, actually your hand is still up rather than up for a second question, or yeah.
Operator error, sorry.
Yeah, as Penny mentioned, there were some kind of limitations and restrictions. I mean, I guess I don't know how familiar you are with the CMD sort of projects, but the phase 1 projects that have just complete were compelled to finish within the financial year as part of the competition rules. So clearly, in terms of what Cox and University of Brighton have done together to redesign that engine is incredible. I mean, I dread to think what Cox's normal product development cycle time is, but I would imagine it's longer than effectively the 9 months.
I would emphasise that it's the work that's needed to turn this into a product is significant. What we've done is a demonstrator to help with understanding, and that it really worked very well to do that. But there's much more work needed to turn this concept into something that Cox could sell.
Yes, exactly. Yeah, so as a proof of concept, it demonstrates what can be done, and I guess we're hopeful that in the next phase there's opportunities. We're expecting that to be launched imminently, expected to be longer duration projects. So hopefully opportunity to take it further, isn't there?
Yeah.
Okay. Any other questions? I'm aware we're going to be pulled out into the main room at 25 past. Possibly time for one more. otherwise. I mean, I have a question, Penny, actually. I mean, for me personally, I think the team as well, it was an incredibly interesting project. It was our first kind of dip, if you like, into significant maritime projects. And for me, working with such a great diverse consortium, 10 partners, was just incredible. But yeah, what was your most interesting? Obviously, lots of interesting aspects, but what was your most interesting discovery, do you think, during the project?
Yeah, I think, because for me, I'm with you that the consortium was really interesting because it had the digital twin activity in which I'll confess, hadn't worked closely with before. So it was really good to see the kind of level of detail that IOTIX and B4T brought to their models in terms of sensors from engines and around the port. Then linking with NGAS's work with the electrolyzer was great to see how it might be implemented on the shore. In terms of us, for me, it was really, personally, it was very satisfying to see the impact of the research work that we'd done a few years ago on diesel, hydrogen, dual fuel combustion brought into an industrial context. And
brought to life.
Yeah, exactly. That was, on a personal level, that was good. I think some of our biggest learning was around regulatory processes for me, which is a challenge. So it was good to have the support of Lloyd's Register within the consortium, but there's a lot more work needed on that aspect to make sure we can really bring the demonstrators and the products to market.
You did manage to finish your point, Ian.
Sorry, Rachel, we didn't.
We were looking at the clock.
I think you got the gist.
Yeah.
Thanks.
Yeah, thanks, Marlene,
for coming back. Thanks everyone for coming back into the main room, and it's really great to see some of that collaboration already starting. I know we've had some interesting conversations. Tom, you wanted to share some final thoughts and reflections just very briefly before we close up today. While we're waiting for Tom, I really hope you found today's webinar interesting and stimulating in terms of sort of maybe even starting off some of those collaboration conversations. And it's clear that the Clean Maritime Demonstration Competition is enabling many of these important collaborations, and the extension of it to a multi-year initiative is really welcome. And we're looking forward to imminently receiving more details of the plans to release further funds through UK Shore. Do we have Tom online now? Doesn't look like we do. Okay. Well, I'd like to thank Marlene Mitchell from the Port of Aberdeen, Ian Blake from the Port of Tyne, Ian Lloyd from Siemens, and Penny Atkins from the University of Brighton for their time and significant contribution to today's webinar. And I'd also like to take the opportunity to thank Tom, Richard, and the Connected Places Catapult team, especially for their participation and assistance in the organisation of today's event. I'll be following up to share the output from today's webinar, which will include links to the Connected Places roadmaps that have been referenced today. And of course, if there's any issues that you would like to explore more directly with me, or if you'd like me to facilitate any more connections, or even details of our future ports and terminal groups activities, please do reach out to me at SMI. We're always happy to help. I think we've got Tom briefly back online. If there's anything you'd like to add before we close, Tom, you may have some thoughts. You are muted at the moment, but you are online.
Sorry, Helen, was that me?
Yeah, just any final thoughts to close, or any reflections from your point of view?
Yeah, thanks. For some reason, all my audio suddenly catastrophically failed as soon as I was ejected from the breakout room. Anyway, I'm back. Yes, thank you very much, Helen and SMI, for hosting us today. I think it's been really great to see some of the projects that we've been involved in come together. Like I mentioned earlier, I think what's been really great about things like the Clean Maritime Demonstrator call is how it really shows what we're capable of and the capabilities we have in the UK, from small organisations of 1 or 2 people all the way through to multinationals with tens of thousands of employees distributed all over the world. And I think Absolutely, 100%. The shift I've seen in the industry, even over the last couple of years, on that imperative, that momentum to actually get things done, I think is absolutely fantastic. And yes, really looking forward to Clean Maritime 2, where we can think on a bigger scale, where we can do bigger things. And, you know, if this is what, just a brief snapshot of what 3 projects out of the 55 achieved in 6 months through supply chain crises, and, you know, we still had the back end of COVID and all the rest of that. Let's see what we can do in 2 years. Really looking.
That's a great call to action.
Yeah.
Absolutely. Thank you, Tom. Really appreciate that again. And sorry you had difficulties coming back in, but yeah, absolutely. If you'd like any details about exploring any more issues or connections, do get in touch. But in closing, thank you very much for joining us this morning, and goodbye.